All right, Precalculus, we will start hyperbolas today. This is section 10.3, day 1, and it goes like this. A hyperbola is a set of points. Remember, we're doing all these definitions. A circle is a set of points. They're all the same distance from the center. A parabola, like this, is the set of points where there's a directrix and a focus, and every point is equidistant from both. An ellipse had to do with the sum of two distances being constant, and so a hyperbola is a set of points where the differences of the two distances from two foci, plural for focus, is constant. In an ellipse, it was the sum. In a hyperbola, it is the difference. So let's just run with it instead of me trying to over-explain it here. One major difference from ellipses, where there will still be a center, there will still be vertices, and there will still be foci. So it's very similar to an ellipse. But in the hyperbola, a focus is actually further away from the center than the vertex. Okay, that's an important distinction between these two. So look, I got a point right here in the middle, and I'm going to call it a center. I'll kind of do these on a diagonal. I don't know why these little dots are in here. They don't need to be there. Anyway, this point is going to be a vertex. So obviously, I'll put a V for vertex there too. Then in an ellipse, if I was drawing an ellipse here, the focus would be in between these two. But in a hyperbola, the focus is on the other side of the vertex. So we'll put a focus all the way out here, and we'll put another one there. That'd be like focus 2, right? So that's an important distinction. The distance from the center to the focus, which is C, is going to be longer than A this time. There still is a B. We just don't connect it to anything. But we're going to use it to graph these. I'll show you in a little bit. Okay, a hyperbola has an axis that's similar to a major axis in an ellipse. Okay, so here's my hyperbola going up and down. The axis is going to be vertical right here. Okay, it goes through the center and it goes through the vertices. Okay, we're going to call it the transverse axis. Fancy name, transverse axis. Why we don't just call it a major axis like we do with an ellipse, I don't know. Just people like to complicate things, I guess. So look, I'm going to go, here's vertex, and here's a vertex. I'm going to connect it with a line segment and put an arrow and say that is the transverse axis. Okay, the distance from the center here to the vertex is A, just like it was in an ellipse. It was the distance from the center to the vertex. But now here, I'm going to put a focus down here, and I put a focus up there. Now look, I'm going to go this distance from this line to this focus. That distance is C. In a hyperbola, the distance C is longer than the distance A. Okay, C is greater than A. That's not true in an ellipse. That's true in a hyperbola, and that's going to come into play when we go to do some calculations later. But we don't got to do that now. Now we got to figure out what this graph looks like and how to graph it and blah, blah, blah. So instead of me boring you by taking the distance formulas and subtracting them and making some kind of proof out of it, I'm going to just go right to the equations, okay? Because it's so similar to the ellipse. If you're going to have a horizontal transverse axis, what would that look like? That would be a hyperbola that looks like this, sideways. Horizontal transverse axis. Okay, this is what we get. X minus h squared over a squared minus y minus k squared over b squared equals 1. There's your equation. Now, it is not necessarily the case that A is bigger than B. It is the case that there's a negative sign in this equation, and the fraction with the negative is the smaller of the two axes, so to speak. The one with the positive fraction, that's going to be A, the length of the transverse axis. That's different. It's not just which one's bigger this time, it's which one's in the positive fraction. Okay, and so the other option is y minus k squared over a squared minus x minus h squared over b squared is equal to 1. That would have a vertical transverse axis. So I would have a hyperbola that looks like that, definitely not a function, right? With a vertical transverse axis. Now, here's the case that the a squared, the positive one, is underneath y squared as opposed to being underneath x squared. Make sense? Okay. Well, here we go. I'm just going to graph a hyperbola. I'm going to show you how to graph these things. The positive fraction is this one here. So I've got a equals 6, and it's underneath x squared. So that makes it a horizontal transverse axis. So the branches won't look like that. They will look like this. These two things are called branches. Now let's find the center. All right, the center is at -3 and 2. So I'm going to go to -3, 2. 1, 2, 3, 1, 2, and put a point. That's the center of my hyperbola, and the branches go that way and that way. All right. A is 6, and so what that means is I'm going to go 6 units. 1, 2, 3, 4, 5, 6, and put a vertex. 1, 2, 3, 4, 5, 6, and put a vertex. Now, if I'm a real math person, I'm going to actually say what those vertices are. So we'll go down here, and I'll put vertices. All right. I went from this center, and I added 6 and subtracted 6 from the x value. So if I subtract 6, I'm going to get -9, 2. And if I add 6, I'm going to get 3, 2. There's my 3, 2, and there's my -9, 2. Okay, b is equal to 2. B squared is equal to 4, so b is equal to 2. Let's see how that helps us. I'm going to go up 2, I'm going to put a dot, I'm going to go down 2 and put a dot, and it's not actually part of the hyperbola. The hyperbola looks like this. So why do I need it? Well, to make a box, of course. So look, I'm going to make a dotted box, or a dashed box, that contains those 4 points. All right, you see it? I went 6 right and left, and I went 2 up and down and made a box. Now my next thing, I'm going to connect the diagonals. Got to turn around and get a ruler out of my desk drawer there. I'm going to connect the diagonals with a dashed line. Right through the center, right through the 2 corners of the box. So let me make this diagonal also. I'm going to go right through my vertices there, go through the center, go all the way to the bottom of the page there. Okay, I made a box by going 6 to the right, 6 to the left, 2 up and 2 down. Made myself a rectangle. Proud of myself. Now, this vertex and this vertex are part of the hyperbola. Nothing else really is. That's why it's all dashed. Here's how you draw your hyperbola. You make it go towards the dashed lines as if they were asymptotes. That's how you graph a hyperbola. Hope that makes sense to you. Now I'm going to get a marker. I'm going to blue this up for you guys so that you can see this is the actual, that's the actual hyperbola. Cool? Of course it's cool. You kidding me? Now I should be able to find this focus in here. All I was asking you to do right now is graph, but if I asked you to find the focus also, we got to find the value C, which is longer than A. We have a, we have a B. There's going to be a Pythagorean theorem thing, but we're going to find out that C is the longest one, so it's going to be a little different. We're going to do that tomorrow, not today. Okay, here we go. Let's move on to the next one. A is equal to 4, and look at this. B is equal to 5. It's even bigger than A, but we don't pick which direction the hyperbola goes by which one of these is bigger. We pick by which one is the positive fraction. There's a minus making a negative fraction. This is the positive, and it's y squared. So this one is going to go up and down because it will have a vertical transverse axis. Let's find our center. The center is at the point 0 for x and 4 for y. I don't know how well you can see this. Sorry about that, guys. So I go 0, 1, 2, 3, 4. Ugh, I got a yawn. Sorry about that. This is my 3rd video I've done today. Getting a little tired. So A is 4 units. So I go 1, 2, 3, 4 units up. And then 1, 2, 3, 4 units down. If I wanted to find those 2 points, I'm going to do it again, vertices, even though I'll probably draw through them again. Add and subtract 4, so that's up and down, so I add it to here. So it's going to be 0, 8, and it'll be 0, -1. Wait, did I do that right? I'm supposed to go 5, aren't I? No, I'm supposed to go 4. 1, 2, 3, 4. 1, 2, 3, 4. Oh, that should be at 0, 0, and I just don't know how to count. That's kind of funny. I'm a math teacher, and I don't know how to count. You should be embarrassed. Okay, so the 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5 points that way. And here we go. Make the box. Here's my box. Then I'm going to connect that diagonal. I'm going to make the diagonals by connecting the corners here. Go right through the center. Make myself some solid dashed lines right there. That gives me a direction for how to make my hyperbola. Okay, and then I go to this corner. There we go. And then I go to that corner. That's good right there. And then I'm just going to make some dashed lines here. Those tell me how to make my hyperbola. Now, before I draw it, I'm going to go back and make sure I did this right. Okay, this y squared is the positive one. It goes up and down, so I'm not going to draw here. I'm going to draw here. Here we go. It goes, where's my vertex? My vertex is right there. I'm going to go along this, and then I'm going to hit that vertex. And then I'm going to go up, and I'll go along towards as if this line were an asymptote. Go through the vertex, and then curve along towards my dotted line. Let me get my marker and whoop this up for you. This is definitely a wider hyperbola than the first one, and the reason for that is the B is bigger than the A. That makes for a wider hyperbola. How about that? All right, look at that. You just graphed 2 hyperbolas. You didn't even know what one was yesterday, for crying out loud. I'm so proud of you. Okay, so here's 2 more. Why don't you graph those 2 on your own, see how it goes, and we'll start the next video. I'll do them too, and you can check. Good luck.